Hello, today in this video we're going to talk about how we can find out the measurement of this angle, which is DBC. Whenever you are describing an angle, you need to describe that angle with the help of the arms and the point of their common vertex. So this is going to be DBC. Now, if we want to find out this unknown, which is DBC, look, it's a part of a triangle. It's a part of the triangle. If you're going to look at PN, it's DBC, a triangle. So if you want to find this unknown, you must know the rest of the two angles. And if you know the rest of the two angles, then you can find out this angle. So we want to find out this angle and this angle. But we can easily find out this angle, which is BCD. Why? Because we can see here this A, B, C and D. This is a cyclic quadrilateral because the vertices of this quadrilateral are on the circumference of the circle. And if you have a cyclic quadrilateral, opposite angles are equal. So it means this angle, which is DAB and the BCD. The sum of these two angles will be 180. So 68 plus the angle opposite to this one is, which is C. And if I'll describe this angle with the help of the arm, so it is BCD. So 68 plus angle BCD, that will be equals to 180. And if we want to find out the angle BCD, that will be equals to 180 minus 68, and that is simply 112 degrees. So it means this angle is 112 degrees. Now we got this angle, which is 112. And as you know, in this triangle, we want to find this unknown, this third angle. For this one, we must know the rest of the two angles. So we do know one of the angles is 112. But what's this other angle, which is BDC? Now, you're going to look at this in very much carefully, that here we're going to use the tangent circle theorem. Okay. So what's tangent circle? What's tangent? Tangent is a line which is touching your circle at only one point. So now you can see this line EF, it is touching the circle at the point C. So it means it's the tangent to the circle. And this thing AC, that's the chord. That's the chord. So it means the point where this tangent is touching the circle and one point of the chord, they are similar. Now the angle between this chord BC and this tangent EF, it's 50. It's 50. Now we're going to use here the theorem of tangent chord theorem or the alternate segment theorem, which says if you have an angle between a chord and a tangent on one segment, like what's its segment? So what a segment means when you're going to have a circle. So if you're going to have a circle, every time you have a circle, and if you will make a chord between the circle, so what the chord will do? The chord will divide the circle into two halves. Okay. Now you can see one is this one and one is this one. Okay. This portion is going to make, these are called the segments, where this is called the minor segment because this is smaller one, and this is the major segment. So similarly here, if you're going to look at this chord is dividing this circle into two segments. One is this segment and the other one is this big segment. Okay. Now this angle, which is between the chord and the segment and the tangent, is in this segment. So the angle this chord will subtend in this big segment, in this major segment, which you can see here, the angle which will be subtended by this BC is, because you can see BC is the arm, so it is subtended here at D. Okay. So that angle will be similar. Okay. So if this is 50, this will also be 50. Okay. So now you have the angle 112, 50. So you can find out this third angle, because in a triangle, sum of all angles inside a triangle will be equals to 180. So that would be 50 plus 112 and this angle CBD. This angle CBD, that will be equals to 180. 50 and 112 is 261. So it will be 162. And angle CBD will be equals to 108. So here CBD will be equals to 180 minus 162. And if you want to subtract, it will be 8. 10 minus 2, 8. And 7 minus 6, 1. So this will be 18. So this angle, which is the unknown angle, now we figured out this angle, and this is 18. Okay, so that's it for today's video.